They're only naturally getting exposed to breast milk. So they're not exposed to a lot of xenobiotics or
Oh, I see.
foreign.
It sounds like what you're saying is so we have a whole family of enzymes called cytochrome oxidase enzymes. In a fully developed individual, in an adult, those are mostly in the liver. They're not only in the liver, but most of them are in the liver, which is why we think of drugs as being metabolized mostly in the liver. But in a neonate or in a very, very young individual who's not fully developed, that whole system in the liver is maybe not fully online yet. And so a higher proportion of the drug they're exposed to might get metabolized by enzymes elsewhere, such as in the brain.
Yeah, that's the first thing. And then the second thing is in the neonates, and this has been known in humans for a long time, that one of the safe pathways, there's two basic phase 2 safe pathways. One is called glucuronidation, and the glucuronidation pathway in babies just doesn't work. It's just
it's
not
just not online
performing.
yet.
It's not online yet. It takes a week or three to get it online. And ironically, every veterinarian knows that a domestic cat, Felis domesticus, cannot get acetaminophen because it's dangerous to them because they're deficient in glucuronidation.
Hmm.
So just nobody connected the dots
Hmm.
that, hey, we know that babies don't have glucuronidation. We know that our domestic animals can't get acetaminophen if they don't have glucuronidation. So maybe, just maybe, this drug might not be the best for a baby. It was just never, they only check for liver function. And we know that you can kill a neonatal laboratory animal with acetaminophen without hurting its liver. That has
Hmm.
been demonstrated. You can give it so much acetaminophen that it dies, but the liver will be fine.
Wow. Okay, so metabolism changes as we develop. It takes time for some of these metabolic pathways and for the liver to fully mature and come online in a baby, in a very young animal. And so if you give drugs to an adult animal versus a juvenile or baby or even, developing animal in the womb, it's going to get processed very differently and it's going to end up doing very different things because all of the metabolism is different at all of these developmental stages.
That is correct, yes.
And I mean, when you say it out loud, it makes perfect sense. Like, well, of course, like it takes time for stuff to develop during development. That's the whole point. Things are being built, they're coming online. Therefore, things like drugs, like acetaminophen, will plausibly not be processed the same way in a developing animal as in a fully developed one.
Yeah, and
But
yeah, every clinician knows that a baby is not just a small adult. I mean, that's the
right,
classic statement of it. But unfortunately, when acetaminophen was approved, not by the FDA, but basically by a collection of physicians working with a pediatric association, they were only looking at liver function, which is with the underlying assumption that the babies are metabolizing in the same way that the adults are. And it's just a tragic mistake.
right. Yeah, just unexamined assumptions. So take us back to the history here. So we had that gentleman who was a dentist. He had a child. The child developed autism. He literally quit his job and got a PhD. And he saw some of the first evidence that maybe acetaminophen had something to do with this.
Right. So then if in 2008 you'd start looking around, and one guy did, his name is Peter Good, and he wrote a paper about this. He's looking at the bigger picture saying, hey, look, first of all, it's known that children with autism can't process acetaminophen very well. That paper had been published in the 90s,
Hmm.
but apparently no toxicologist to look at it. So remember I said there's two different phase 2 these safe pathways. One's glucuronidation. Babies just don't have it. The other is called sulfation. Well, it turns out, and this has been confirmed repeatedly, that babies or children with autism have very poor sulfation sort of pathway.